Ma'am, when everything ready, please let me know.
Yes, sir.
All good? Shall I proceed or you want to wait
So
for
we'll
some
have to
time?
wait just for 5 minutes as the participants will be joining with
Okay.
the new link.
Okay.
So you may start, I think.
Yeah, we will because now I am audible, right?
Yes, sir. Now you're audible.
Okay. So once there is a break, we understand the situation. It doesn't matter. Shall I? Shall I?
Yes, sir.
What?
Yes, sir.
Okay. Okay. Right. Slide is visible.
Yes, sir. Yes, sir.
Shall I run slideshow or I'll? Okay, let me run this slideshow. Fine. It is okay now, visible, right?
Yes, sir.
Okay, thank you. So once again, I apologize maybe if any difficulties from my side. Um, let's cover up and I promise I'll be completing on time, whatever possible by me. So I have decided to take up the topic intelligent system design. Since your FDP is on decision science, analytics, and virtualization tools, so when you want to take a decision, probably you need to be intelligent. And for that, when we were designing any system, we would like to take a decision on its own. So eventually, we need to design an intelligent system. And for designing intelligent system, there are a number of approaches. And one of the approaches which I practice or I research with my students and collaborators is computational intelligence. You may call it even ML, machine learning, or you may call sometimes soft computing or even AI. So this is the topic which I have chosen to deliver today, whatever the time there. So what exactly it takes to design intelligent system? When you want to design any intelligent system, first of all, we need to know what is that we need to think of. Shall we think of process? Shall we think of outcome? Shall we think of input or data or control? What should we really think of when you want to design any intelligent system? So in my view, there are a number of aspects which we need to concentrate when we are designing any decision system or intelligent system. The first one is input, sensing the world. You need to take the data from the world, so it means you have to sense. So like human body is having eyes, nose, mouth, hand, you can feel, you can touch, you can smell, you can test, you can hear, you can see. So many sensors are there in our physiological body. Similarly, when you want to design any intelligent system, you definitely have to have some input. Sometimes the input might have to be recorded automatically with the sensor system, IoT and all, or sometime user probably has to give in tabular format or maybe in image format or sound format, multimedia format. So there are a lot of ways you can submit the input data to your system. For that, probably you need to study DSP, digital signal processing, image processing, some kind of statistical data collection. You have to filter the data, you have to normalize the data, you have to reduce the redundancies, or handle the missing values. So all that pre-processing you have to do. So sensing the world, in my view, while designing the intelligent system, is the foremost thing, because that is the system where you collect the data, you give the data to your system. So you have to focus, of course, on this primarily. Second is, once you have sensed, what next? Once you have given, now the question is, uh, this is data, this is not information. Data and informations are different. Raw facts and figures are data, semantic or meaningful facts and figures are information. So you have submitted the data, but then what about the information? I need to extract the information from this. I might go to the market and buy vegetables, but raw vegetables will not have any meaning. It has to be cooked to different type of dishes. So that is what extraction of the information about the data which you collected in the first stage, the sensing the world. Next stage, you need to find out what are the feature, what are the relevant feature, what are the feature necessary, what are the feature not necessary. And that can be done using feature extraction techniques or neural network techniques, or you may use even the fuzzy linguistic learning, or you may sometimes have to compress the data. So these are the areas we need to focus when you are extracting the information about the data. This is the second aspect. Third aspect is, once you have extracted the information, recognize the state of the world, because the world state is changing, the machine state is changing, your system state will be changing. The state of the machine will be X when there is no data. The state of machine will change from X to Y when it was submitted with the data. For example, when you are not listening to me, you are having in one state. When you are listening to me, you are having in another state. And when you try to extract the information what I have told, then you go to the another state. So you see, three states of yours are there now. First, you are listening, sensing. This is one state. And then when you extract the information, you move on to another state. And similarly, if you recognize that, yes, this is what I need, this is what I do not need, and then you are in another state. So recognizing the state of the world is very important, and that plays a major role. And there you have pattern classification, pattern recognition, you have forecasting, you have regression, you have decision tree, you have SVM, all that comes under this statistical and other detection theory. So that is the recognition of the state. You must have done many classification algorithms. You must have done any clustering algorithms. That comes as the third state. But please, my dear good friends, remember, third state comes only after the first two states. You cannot ignore the first two states. Otherwise, your third state will not have any relevance. The fourth one is, once you know the state of the world, then what you need to do? Predict. the behavior of the world, how it is going to interact with the world, how it is going to behave with the world. Because any system which you have designed, it is not for the sake of your laboratory experiment, or not for the sake of your API index, or not for getting some publication or patent. This must be usable. This must have some kind of usefulness to the society. And for that, you need to predict the behavior of the world. You need to do some analysis. We have a number of such theories coming under these, like probabilities model, time series analysis model, dynamic system theory model. So these are the technologies which you need to understand under the fourth important aspect of the intelligent system, known as predict the behavior of the world. What next after the prediction? Once you have predicted something, the immediate question will be reasoning about the world, and plan action. When you predict something, then next question will come: how do you say this? What is the certainty? What is the reason behind it? See, I just cannot say today it is going to rain. I must have some reasons behind it. I must have some kind of theory behind it, some hypothesis behind it. I just cannot say this boy is going to get a job, or this boy will not get a CGPA above 9 point something, or will get 9 point something. So if I say this, I should have some reason about the world. Once you have that reasoning, and that reasoning is nothing but your artificial intelligence, you need to have some if else statement. You have to have some cognitive action, cognitive thinking. And then once you reason, then you can plan some action. Then only you can say, okay, this is what you have to do. So that is why, unless you do the prognosis, you really cannot do any actionable things. So you need to prognose, you need to predict, you need to reason, and then only you can plan action. So your intelligent system will go through one, two, three, four, five stages, but it is not over. The sixth stage is the most important stage, which I would like to mention, is act on communication with the world. You have taken the input, you have extracted information, you have recognized the state, you have predicted, you have done the reasoning. Then what? Act on, communicate with the world. If you really cannot communicate with the world, if I know, but I cannot speak to you, there may be some teachers who are very good teachers, but really they cannot deliver. So that sometimes is a bottleneck. There may be a student who is really intelligent, but he cannot write in the examination paper. That is definitely a problem. A student might be knowing everything, but when he goes to the interview board, he can't really communicate. Then you always say, hey, just knowing is not enough. You must act on, you must communicate with the world. And there comes control theory. There comes robotics. There comes information and communication theory. So you see, these six are the most important ingredients when you are designing an intelligent system. And for any decision science, for any decision scientist, these six are essential. And you will be surprised. You may definitely understand from here that you might be doing all this, or you might be doing few of this. And people are doing research on any one of these, or maybe all of this, and they are getting PhDs, they are getting theses, they are getting papers. So intelligent system design, if you see, it is just not limited to AI. It is just not limited to one aspect of our technology. It is entire thing. You can see your mechanical engineers have the role to play, mathematicians have the role to play, electrical people have role to play, everybody, your statistician also, they have the role to play, electronics people, image processing people, they have the role to play, and computer science people also have the role to play. So if you look at, while you are trying to design any decision science system, it is this. People have this myth that data analytics means just run some kind of Hadoop network, or Python, or R programming, and run the codes and get it. As far as my experience goes, I don't think that is correct. Intelligent system design or data analytics or decision science are very much fundamental, mathematical, and core branch of electrical, electronics, mechanical, etc. So we need to understand it when you are designing something. Now, if you can see in all all these thing, you are dealing with data, you are playing around with data from the beginning to the end. When you are inputting the data, that is the first step, and you are acting or communicating with the world, that is again the process data, some kind of information, some kind of decision, some kind of intelligence, some kind of wisdom you are giving to the world. So in between, rest all four stages are also dealing with the data. Now, what are that we are going to, what we are actually doing with the data? Look at the next slide. All applications today are data intensive applications. I mean, we are dealing with data, 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 data. Somebody has said that data is the new electricity now. Data is the new oil now. And there is a lot of data explosion. People are saying in another way also, we are all data rich, but information poor. We have a lot of data, but we are not able to extract the meaningful data from this. So we are, as far as informations are concerned, we are really poor, but we have lots of data. We might have lots of papers downloaded in our desktop. Every one of you are teacher, you are doing your work. So you are all doing lot of work on the data. Now, what is that you are doing? If you look at this, you are actually doing these five things. Understanding data is really very tough. I hope I am audible to all of you. Anyone can respond? Just for check, am I audible and visible?
Yes, sir, audible.
Also slide is visible.
Yes, sir,
Yes, sir.
visible.
Yes, sir. It's visible.
Yeah,
Visible, sir.
yeah, just wanted to check because
Yes, sir. Yes,
technically it
sir.
was not working properly.
Yes, sir.
So I'll quickly wind up because I don't want to take more time. We have lost the time, and I know you people must be impatient. So, but very interesting things are there. I had it in my slides to cover up. I'll try. Data intensive applications I was focusing on. Understanding data is really very difficult since the meaning of the data changes over time. Over time, it changes. Whatever the data, suppose you give me a sentence, whatever I understand now, after 5 years, if you give me the same sentence, I may understand it different. After 10 years, if you tell me the same sentence, I may understand the different. So that's what I say. The data really changes, the meaning of the data changes drastically over the time. Just for the sake of little humor, I just heard somewhere this beautiful anecdote. Let me share. 5 years baby, a boy goes to his mother and says, "Mom, I love you." See the data, "Mom, I love you." Then mother understand 5 year. 5 year. The boy is 5 years old. Then mother says, "I love you, beta." जब वो लड़का 10 साल का हो जाता है, 10 years, he goes, or let's say 70 16 years, 16 years हो जाता है, when he goes and says, "Mama, Mom, I love you." Then mom says, "How much of money you need, beta?" Look at the same sentence. The first sentence and the same second sentence same, "Mom, I love you." But the time is difference, 5 years to 15 years. 5 years mom understand, okay, मेरा बेटा मुझे I love you बोल रहा है, तो I'll definitely love him. 15-10 साल का बाद जब बेटा बोल रहा है कि आई लव यू, तो मम्मी सोचती है कि शायद उनको कुछ रुपया चाहिए. Then she is asking, how much of money you need? Look at the interpretation, look at the meaning. Another 10 years after, when this boy becomes 25 years, and he goes and says, "I love you, mom. Mom, I love you." Then mom says, "Who is that girl?" Because it is 25 years. Mom is now understanding why suddenly my son is coming and asking me, "Mom, I love you." Definitely कुछ तो गड़बड़ है. Then she's asking, who is that girl? 45 years, another 20 years elapsed. 45 years. Gentleman comes. That boy has become now gentleman. Married that girl. And comes and says, "Mom, I love you." You know what mom answers? "I told you no, don't marry that girl." Look at the interpretation. Because at 45 years, he should say, "Honey, I love you." But he is saying, "Mommy, I love you." कुछ तो गड़बड़ है. Understanding is different over the period of the time. When he reaches 65 years, और 20 साल elapse हो गया, 65 हो गया, and by the grace of the God, the mother is alive. He goes and says, Mom, I love you. And mom says, I am not going to answer. I am not going to sign on that property paper. Look at the same sentence, but the answer is different. The interpretation is different. So, what is the meaning of this? The meaning of this is a beautiful study on data. You will be seeing that same the cow essay is written now by a fifth standard student and also one graduate student. But there is a difference understanding. So same data somebody is using, he might be thinking about description, hindsight. He must be thinking about what happened, descriptive analytics, hindsight. Some other might be thinking about what is happening, oversight, diagnostic analytics. Why did it happen in this data? Diagnostic analytics. Some other guys must be working on what will happen. See the past, what happened? What is happening? The present, oversight. What will happen? The foresight, predictive analytics. I'm going to predict. And again, some people may think about how can we optimize what happens? Insight, prescriptive analytics, prescriptive analytics. And the other group may think about the right side, cognitive analytics, 360-degree view. They might be thinking about what is the right action, what is the right decision right now for this set of data within this specific context. Because we need to see the context of that also. Because if the context changes, things will change. I buy a vegetable, I buy potato. If it is a potato plain curry, then the preparation of that is different. If it is a French fry, then the preparation is different. So I need to have some 360-degree view, and I call it cognitive analytics. Friends, these are the 5 analytics we do on the data. And these are the 5 analytics we have to focus when you are designing any decision science system or analytics system. And these 5 things can be visualized in a different way. Visualization tools. I need to use some tools. There are a number of tools are available. I think in this FDP, number of maybe few of the tools might be exposed to you. So you can use those tools to see what is the hindsight, what is the oversight, foresight, insight, and the right side. So 5 sides are important for us. Then only you can design one intelligent system. Intelligent system designing is not just you just make a model of the ANN, give some data, run your backpropagation algorithm, and make some analysis and give a curve and table and say that okay, in my model this is working better than that is working. Other one. Compare 4, 5, 6, and then give. Yes, that is required. I don't deny. But then those 6 stages which I have given you in my first slide is very much essential because you must communicate with the world. It must be usable. And you need to see the right side of this. You can't just take this will happen. You have to see what happened, what is happening inside, and what might happen. And once you know 3 things, then you need to do how do I optimize? How do I get my best results? So these are the 5 important aspects which I have understood in my working with the data science or decision science. And based on this, I developed my designing or whatever little I could do with my students, I keep on doing it. Now, when you have done intelligent system design, how it is really helping you? If I make my machine intelligent, how it is going to help you? Look at the figure in the left side. It is taken MRI figure, magnetic resonance of the brain. And this is what coming after some pre-processing from the machinery. Looking at this and looking at the other side, you can see some of the automatic features are detected using our data science tools, data analytics, computational intelligence. Now, if these 2 pictures given to a doctor, A doctor will be definitely able to diagnose better in the right side image because you will have all that right side cognitive 360-degree view. He can look at each and every portion, the region of interest, ROI, and he can identify, okay, here is the problem. And that is the power of designing some kind of system based on the automation. And this is an automatic medical diagnosis. Now, what do you do in this? Simple thing. What you do is you have some input space and you try to convert it to a feature space. There are some red and blue dots. If you look at the input space, you are confused how they are. But if you look at the second feature space, you can definitely see some of them are on top, some of them are on the bottom, and that is what called extraction of the feature. Pattern recognition. You can see the pattern from this. So this is a decision making. If this feature space is given to me and I'm a doctor and my decision making will be fantastic. But if the input space is given to me, probably I might do mistake. If I am experienced, I can say. If I am inexperienced, I can do mistake. So as computer scientist, as researcher of the machine learning or computational intelligence, our main objective is to augment the doctor or augment because mostly why I take the example of the doctor because most of my works on the healthcare field. I work for the AI in healthcare. So that's why I have taken this example. So we need to augment the doctor. We need to support the doctor. So similarly, a lot of examples can be given. And there are a lot of application of this machine intelligence, or you may call it computational intelligence and application. It's control and application in the variety of the fields. So decision science is not limited to only a particular commercial system. It may even go to all branches of the engineering. And as data scientists, as researchers, as faculty members, our objective is to really motivate. You can see a beautiful diagram there. I think can you see a beautiful diagram? The two hands are there and one button is there. If you can see very clearly, I hope it is visible. I have purposely taken this diagram because it depicts a beautiful anecdote or a concept. If time permits, I'll definitely tell it, but let me go ahead. Now, where I can apply my decision science system in weather and natural disaster prediction, speech and image recognition, biomedical engineering and diagnosis, manufacturing of the robotics, automotive system. See, I can just go on stock market, economics, aerospace, electromagnetic device, computer games and virtual reality, genomics and bioinformatics, agriculture, industrial. You can just go on adding. So decision science is not really just confined to the computer engineering. It is a branch which is the conglomeration of most of the engineering sciences, engineering branches, including science, social science, and management. Many of you must be working on this, I'm sure. Many of my colleagues who are in this platform must have completed their PhD, and somewhere or other, they must have some kind of relationship with such kind of system. When you are thinking about such kind of system to design a decision science system, immediate question comes: what you require, what you need. Basically, I think three things I would say the starters would think of. If I'm a starter, if I'm guiding my students, BTech undergraduate, or maybe MCA, or maybe PhD, I would tell them, if you want to design any intelligent system, or if you want to design any kind of system which will support the world, please understand three things. What is that? Because my brain is the most intelligent system. If I understand my brain, how it works, what are the ingredients there, I think I can mimic it. So what I need when I design one intelligent system, first I need one artificial brain. I need to know how I can mimic my artificial brain, or in other words, artificial neural network. I would teach my student first ANN, that you develop ANN first. You understand what is artificial neural network, how it is working, what is hidden layer, What is number of hidden layer? What is backpropagation algorithm? All that I'll train him first with small, small toy problems. Because he should understand the brain first. Once he understands the brain, second thing what I'm going to teach him for developing a decent system or intelligent system is linguistic reasoning. Because almost all inputs are now in terms of linguistic. We say today it is it is bit cloudy, or it is a little darker, it is brighter, this fellow is taller, this fellow is smaller, I'm feeling little fine, I'm feeling little uneasy. These are the linguistic terms we give. And our present day computer system, the digital binary computer system, works on the binary 0 and 1. It will either understand that it is darkest or it is brightest, whether it is tallest or it is shortest. But it cannot understand whether it is taller than somebody and shorter than someone. If I say 4 feet and 6 feet, 4 feet is the shortest, 6 feet is the tallest, then what about 5 feet 11 inch? I cannot capture this information if I am doing it binary. Because linguistically, I say this boy is more taller than shorter. This input is more accurate than having more error. If such kind of linguistics are given, how do I really convert it? Because most of the data which we will be collecting will be in this format. Most of you must be knowing about recommender system, about emotion recognition, emoji recognition. A lot of things you guys are doing, NLP, natural language processing. And all those inputs are nothing but in terms of some linguistic variables. Unless I quantify, unless I convert it some kind of numbers, I really cannot crunch it in my machine, because my machine is a number crunching system. It will only crunch the number. It cannot take what is the meaning of taller, shorter, brighter. No. You give some number for taller, it will take it. You give some number for shorter, it will take it. So how do I deal with such kind of linguistic reasoning? Obviously, fuzzy logic. So I have to teach my scholar or my student or myself, I have to learn first fuzzy logic. I have to create some membership function. And in that membership function, I can say, yes, this is belonging more to that area than to that area. Then I can quantify it. Once I quantify, I get some real number. And then I can go for my number crunching system. So first thing is brain, artificial neural network. Second thing is that I have to do my number crunching using reasoning, linguistic reasoning using fuzzy logic. Once I do these two things, I think I am almost done. I'm almost done in designing an intelligent system. But you remember, I have told you one I have slide. I think I have given you that term. Let me once again go. That is called insight. Insight is very important now. The meaning of insight is how do really I optimize my internal things. So I have my brain now. I know my languages now. I can convert it to some kind of numbers. But next is coming, can I improvise my brain? Because decision science or decision making is more, it is more towards improvisation. You need to optimize it, in other words, technically. So I need to understand the optimization techniques. How do I optimize my parameters? How do I optimize algorithmic parameter, user specific parameters? How do I deal with my error? How do I deal with my model parameters? Because I'm developing a model. So for that, I need to learn some optimization techniques. Mathematics, classical mathematics have a lot of optimization techniques. There are a lot of approaches. There are several classical techniques are there. Lot of works have been done, but very few, still there are a lot of challenges to tackle. A number of techniques are there which are even hybrid techniques. Many new techniques are coming. Many hybrid techniques are coming. Evolutionary computation, EC technique, which is the focus of my talk today, is getting widely popular. nowadays. So I said that three aspects of the intelligent system is design: neural network, fuzzy, and optimization. So in this lecture, I thought of going to the optimization insight first because I must know how to optimize my result. What should I do in my system? Because many of us we know ANN, many of us probably we know fuzzy logic. Even you might be knowing many, almost all you know this optimization technique. But I would like to show the interconnection among those three. Evolutionary technique, why I have chosen that, comes under the category of the computational technique. I have told you computational intelligence for the intelligent system design. I'm taking CI, and CI, under CI there is EC. EC is one such platform under CI, evolutionary computation techniques. What do you mean by evolutionary computation technique? These are the techniques which evolves of its own because it really matches to the human characteristics. It matches to my characteristics. There is no mathematics behind it. When I was a kid, my teacher said A for apple, B for ball, C for cat. She has not shown me the apple. She has never shown me the color of the apple or the practical apple. Or she only told that B for ball. She has never shown me the size of the ball or not told me whether it is a football or a cricket ball or a ping pong ball. But I know as soon as I read B, I say it is B for ball, C for cat, D for dog, and many other such things. How did I learn this? I optimize. This is insight. I optimized myself. I have that capability of improvising myself. Evolutionary computation. That's called evolution. I am evolving day by day. When I was a kid, I used to say only A for few. But now if I ask me what is A for, I think I can list at least 30, 40 what is A for. A for aeroplane, A for attitude, A for attribute, A for so and so, I can do it. How did it happen? Did I go to school to learn this? No. Then how did it happen? It's again, I learned. I learned. And this is the one of the very important characteristics of our brain. Our brain always learns, but machine is programmed. Machine is algorithmic in nature. Brain is cognitive in nature. My brain always learns. It learns by repetition. It learns by remembering. It learns by making mistakes. It learns by seeing others people making mistakes. It learns by doing. So there are a lot of ways I learn. It learns by memorizing. Sometimes you must have seen a boy is remembering and mogging up. And at times, some teachers they scold the boy, hey, you are a mog up guy. No, wrong. Because mogging up is also one kind of learning. We need that also for some time. So, cognitive capability of the human being is one very important capability which is evolutionary in nature. So I learn. See, I am talking to you. If you are able to see my video or myself, you will be seeing I am moving my hand, I am moving my body. Nobody taught me that when you say this, you shrug up your shoulder, or you look at this way or that way. Or when you say, oh, it is very good, you make your facial expression that way. Nobody has taught me this in no school. But how do I do it? It is evolution. It is by experience. It is by looking others. It is by imitating others. It is by practicing. And that is called optimization, evolutionary techniques. So my research area, I focus mostly on optimization techniques. And I have developed two optimization technique on my own. Those are my breakthrough optimization technique in the world. I'm the developer of two new algorithms, which I wanted to discuss in this lecture if time permits, but I'm afraid I do not know. I have two algorithms. One is SGO, social group optimization. You can Google it. SGO, social group optimization. This is my algorithm. Many people are using this in the world, like genetic algorithm, particle sum optimization, differential evaluation. Similarly, I have developed one algorithm, SGO, which became fourth best algorithm in 2016 in IEEE World Coding Competition when I have participated. Later on in 2017, I have developed one more called called SELO, Social Evaluation and Learning Optimization, with my collaborators from Canada and from India. I have developed this SELO. So these are the two evolutionary techniques. There are number of evolutionary techniques are available, but basic approach in the evolutionary techniques remains same. Interesting thing in this area is this research is some works better for some class of problem, but doesn't work good for that class. So that's why there is a need of developing newer revolutionary techniques. The first evolutionary technique became popular from this Spectrum magazine. You can see hundreds of algorithms of optimizations are there. In 2000 February evolutionary competition Spectrum, if you can lay your hand, you will find out that in 2000 only it became more popular. Why we need evolutionary computation technique when we have so many classical technique? Because we have some problems which are hard to solve. Hard to solve doesn't mean difficult to solve. They are NP hard problems, non-deterministic polynomial hard problems. So because of the nature of that type of problem, we need to have some new approach to solve this. For example, traveling salesman problem, vehicle routing problem, graph coloring problem, aircraft scheduling problem. These are all, or timetabling problem for our big universities, timetabling problem are all NP hard problem. So such problems are really becoming very hard if the number of or n value increases. When n value increases, it is two word. Your k means, those who know k means is NP hard problem. If the number of n value increases, then your complexity is, nk t, nkt, order of nkt. If n is increasing or k is increasing, then the complexity increases. And that becomes the NP hard problem. When such kind of problems are there, you need to think of some kind of alternate solutions. It cannot be solved by rudimentary or classical linear mathematics or differential equation or by gradient method or by Newton's-Raphelson method. Then you need to see some kind of other way to solve this, a new way to solve problems. And what is this problem we are solving? Optimizing insight, nothing else. We are trying to optimize some parameters. Why some problems are difficult to solve? That comes the second question. In the real world, you'll find out some problems are mathematically intractable. You can't really derive any mathematics out of it. This girl is beautiful. That girl is not beautiful. Can I write a mathematical model for this? Absolutely no. Then how do I solve? Transcomputationally large source spaces it may require. It may require a large source space, or it has the time varying nature. Whatever the data I'm collecting at this time, another 1 week after, the things may be changed. Or it may be a noisy observations. Or it may have so many competitors. So there are some problems, as I said, K-means problem is one such problem which are really difficult to solve in a computationally less time. So we need to think about the alternative. There are some problem of the classical methods because sometimes it failed to address the real world problem at hand. And other time simplification, lot of assumptions we do, lot of assume, we write initially assume. And when you assume a lot of things, you may get the right answer, but for the wrong problem. Because we do a lot of oversimplification in our classical mathematics. So the question is coming, how can we handle mathematically intractable problem that are time varying, noisy, and don't involve mean square error? We don't have a mean square error. I mean, error is not decreasing in terms of the minus dy by dx gradient method. Definitely, evolution is the solution. Evolution is the solution. And it is a two-step process, very simple two-step process. Random variation, natural selection. You take something, change, and then select it. It's just like that we do when I go to a market to purchase some dresses. Do I run depth first search algorithm? Do I run breadth first search algorithm? Do I learn any kind of search technique which you have taught in this class in the data structure? Tell me, my dear friends. No, you don't run that. Then how do you do? You just walk into randomly any shop and go to any part and get some trouser or shorts or whatever you like. Then you see, no, no, this is not good, this is good. And then you go to another side. You say, okay, then you compare. Then you reject something. And finally, maybe you arrive at your solution. And what is this? Is this depth first search, DFS? Is this breadth first search? We people, we teach all this data structure to our classes and set question paper and tell them, hey, you are not getting good mark. But practically in our life, we don't do this. We don't do this. We do randomly. I want to go to my friend's house. Let's say I haven't seen where it is. I only know the name and all. And then what we do? Of course, today GPS is there. But otherwise, what would have been done? I would have gone randomly to some places, ask few people, then take a right turn, then left turn, then come back. I could have used my intelligence gradually. I could have evolved from that search and arrive at the destination. Because when you do this thing, what happens? You create a diversity. That's very important point. You create diversity. There is a diversification. You are not localized. You will do a lot of variations, and in that variation you go beyond. And this diversity is always heritable. If you make some diversity, it goes to the next generation. And then what you do, you eliminate the inappropriate solutions. You say, no, I don't want this shirt, I don't want this color I'm having, this is more costly, this fabric doesn't suit me. So unless you have the diversity, you really cannot eliminate. If I just give you one dress or one blazer, you have to pick up that, and that may not fit you, that may not suit you. And that is your classical technique. Solution is right, but for the wrong problem. But I need insight of this. I need prescription, how to optimize it, how to go for the evaluation of problems. Evaluation is a scientific method. Many of you must be knowing it. I will not go because I was told by ma'am that up to 45 I can take. Quickly, I'll end and I'll share on the slide. So anyway, this session I thought will be a problem solving session, not programming session. So how do you attack the problem? And particularly the problems are of the two type: computationally hard problem and ill prose problem. There are some problems which are computationally hard. It takes time. And there are some problems which are ill posed problem. I mean, human can do better than a machine. For example, character recognition, face recognition, speech recognition, these are all human can do better. And I am more focused on ill posed problem. Because if it is computationally a hard problem, fine, we have some kind of methods we can solve by both human being and computer. Yes, it takes some more time, doesn't matter. But what about the ill posed problem? These are the two, problems which are computationally hard problems. But what about the ill posed problem? Ill posed problem is this is a simple hard problem, that to find out what is this salary. Fine. But if you want to classify in a bank two categories, which are the good candidate for a bank loan, and second category will contain the other employees who can be given bank loan, who cannot be given bank loan. This is definitely a kind of ill posed problem. I can't decide just based on the salary. I need to have a lot of things. If it is a ill posed problem, I can't solve it by if else then. I need to solve it by experience. In the red, it is written experience. A banker must have a lot of experience. Based on his experience, he is going to make a decision. So look here, my dear friends, decision is now related to the experience. And experience comes from the cognition, practice. So you need to have that cognition, and cognition is again diversification. Unless you have diversification, your experience cannot come. Unless you are not rejected, you cannot be accepted. That's why if you are rejected, you become more cognitive, more experience, and you might be accepted. So the most important thing is diversification, and diversification comes only if it is evolutionary computation. Otherwise, it will not come. So there is a difference between well posed and ill posed problem. Most important thing when you are designing any intelligence system for ill posed problem, four most important thing you have to see: learning, adaptability, robustness, efficiency. Any model you are developing, any system you are developing, it must be able to extract models from the examples. Friends, what are examples? Data are examples only. You always give the data, those are examples. From the examples you should be able to you know learn. For example, now I'm giving so many examples, and what is your brain is doing from your example, from my examples, maybe some of you are able to extract something. That is called learning. Second one is adaptability, dynamic environment. Our system was there at 12 o'clock, we will start and 1:30 we will end. But due to technical glitches for 40 minutes, we could not. The people who again logged in, they're adaptable because they are dynamic to deal with the environment. Some of the friends might have disconnected. Oh, chalo, aaj nahi hua 40 minute, aur kya hoga, kuch nahi hoga. Not at ability to deal with the dynamic environment. That's very important point. I must be able, as I said, I used to do it for Zoom, but first time I'm doing it for the Google Meet. So I must be adaptable. Yes, there are technical glitches, but I must be able to deal with this kind of environment, adaptability. Second is, how do I deal with the noise, incomplete, inconsistent data, robustness? The decision system which I want to design must be robust. It should not always look for, demand for noiseless, incomplete data or inconsistent data. Then no, not possible. I must go to the market and pick up the right potato from sack of potato. I cannot say, no, 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 you don't have the rotten potato in that. That ability I must have. That's called robustness. And finally, the most important point is I must be able to give the answer in the reasonable amount of the time. Efficiency. I should not take long time to give the answer. If you are asking me something and within 2 minutes, 1 minute I cannot answer, then what you will do? You will ask me the second question because efficiency matters. And these four things you can get only using some methods which are available in computational intelligence or soft computing. So friends, probably this is the beginning of my talk. If not, in fact, I have come to the end of the talk, but in fact, this is beginning of my talk because I have set a foundation that why CI, why soft computing? Because of these four important ill-posed problems, four important characteristics of the ill-posed problem. And all of you will be asked to design a decision system or intelligent system or analytic system for ill-posed problems, never for well-posed problems. Because well-posed problems can be easily solved by a system, mathematics. Our challenge is only for the ill-posed problem. And for doing that, you need to definitely depend on some kind of newer techniques. And this is the new technique which I have said. And this is one such technique, as I said, I have developed one algorithm, socio-inspired algorithm. Just quickly, I will browse through. I'll not take more time. Yeah, there are a lot of classes of these algorithms are available. So from this, I have developed the cultural and social algorithm that is called SELO. So let me just quickly go through since I don't want to take more time. And the next one is I have developed from the philosophy of Vivekananda that is called SGO, Social Group Optimization Technique. So this paper is available, both paper available freely on the internet. You can download from the Vivekananda. I have taken and mathematically model his knowledge or his teaching and then solve lot of problems. So these are the different problems which I have solved and with time complexity analysis. And this is the paper with my first scholar, PhD scholar who became gold medal because of this work. And this can be captured by screenshot by you or I'll be sharing it. And you can get entire paper because it was open access paper. We made it open access so that all can read and use this one. So this is a lot of applications are there. As I said, I'm working on mostly, medical science. A lot of applications are there, brain MRI and all. A lot of. I'm not able to show this as I am running out of the time. So this is my mail ID, which you can use if you want to communicate with me. So that's all I wanted to share with you. If you allow me to share another slide, I'll just share so that just a minute. And I'll close it after that. Just a minute. Let me share one more slide with you all. Yeah, hope it is visible to you. This is the journal which I am editing, special issue. It is written, and 3.791 is the impact factor. Complex intelligent system from the Springer. You can submit your paper if you are working on this area. Second one is multimedia tools application from Springer. This is again 2.313 impact factor, no publication fees. and blockchain for secure and optimal multimedia processing in healthcare. This you can also submit. Third one is on particularly COVID-19, AI-based health-related computing for COVID. Again, AJSC is a Springer Journal 1.711. And when you see this, please click article type COE and selection category COVID-19 so that it comes to me. The fourth one is on soft computing Springer 3.01050 impact factor, no publication fees. This is on soft computing in defense system, methods and application, which will comprise of all your image, video processing, security, everything. So you have to only select soft computing in defense system, methods and application. Apart from that, this is another journal which is Scopus Index and ESCI, where I am the associate editor. It is on the iOS Press. All are free journal. It is not having impact factor, of course, International Journal of Knowledge Base and Intelligent Engineering System. So these 5 journals I thought I'll share with you, although there are another 4 or 5 journals I am having, but then this 5 will be very helpful. These are all SCI impact factor. All are free, nothing to pay. If you are interested, you can submit. So with this, I would like to conclude my delivery. I'm sorry we couldn't do much. There are a lot of screens, uh, PPTs are available. With the given time, I could finish it. Thank you very much, Latika ma'am. Over to you.
Thank you, sir. Thank you for the valuable session in such a short time. And thank you for accepting my invitation for giving this wonderful session.
Thank you, ma'am.
Thank you,
Thank
sir.
you very much. Thank you.
Thank you very much.